Welcome to my YouTube channel. In this video, I'm going to solve a fluid mechanics problem. First, I read the question, then I will explain. In two-dimensional flow, a force of 20 pound acts on a small square plate as shown below. Determine the normal stress and the shear stress. The values are given. Data is force is 20 pound. The force applies at the angle of 65 degree, and this length is 0.75 feet. This okay, as the plate is square, as the plate is square, so it has its length and width is the same. Okay, now first of all I will explain the difference between normal stress and the shear stress, then I will solve this question. So normal stress when force applied perpendicular to the surface, then stress is known as normal stress can be divided into two types. One is tensile stress, other one is compressive. I will explain. Tensile is, for example, here is the surface and you apply the force perpendicular to that surface. So when we apply the force perpendicular to that surface, so it means the length of this material increases. So this is the tensile stress. So as the force is also perpendicular to this surface. Similarly, the compressive stress is when we apply force and we compress this material, mean its length will decrease. When its length decreases, so but the force is, main thing is that the force must be normal to the plane. This force is must be the perpendicular to the plane. Okay, now the other stress is that is known as shear stress is when the force applies parallel to the surface, when force acts parallel to the surface. For example, if we have any surface, any material, so we apply the force just like this surface to parallel to this surface. Okay, and also we applied to this surface. Okay, so shear mean it is a stress when which change the shape, stress which changes the shape of material. For example, if we apply the force just like parallel to this surface, okay, when we apply the force parallel to this surface, so this body will tilt, its shape will changes, it will be, its shape will be deformed. Okay, so this is the final shape. We are deforming the shape. Okay, so this is the shear stress. Okay, now in this problem we have to find normal stress as well as the shear stress. So in order to find the normal stress, first of all we have to divide this force into two components. One is the normal component, that is perpendicular component. Other one is the horizontal component, that is this one, parallel component. So this you can see that this component, that is the y component, that is the sine component, 20 sine of 65, this is the force normal component or y component, equal to 20 sine 65 degree, because angle is 60, this angle is 65 degree. So it means we, in this case, when we are going to find the normal stress, we use this force. Okay, 20 sine of 65. Okay. So equation for stress is stress is equal to normal stress is equal to normal stress equal to normal force divided by area. So normal force is F sine of 65 degree divided by area is, as we know that the plate is square, so area is 0.75 feet square. So which will give us force value. Force is 20 sine of 65 degrees divided by 0.75 feet square. So when we solve this, we get normal stress is equal to, that is equal to 32.22 pound per feet square. So if we want to convert this feet into inches, so it means 1 feet, as we know that 1 feet is equal to 12 inches. So it means we have to just 32.22 divided by 12 square, because this is a feet square, we can convert into inches square by dividing this 12 square. So our final answer will be equal to 0.22 pound per inches square. Now for the second part, that is the shear stress. Shear stress, we use horizontal component of force divided by area. The horizontal component is, as we know that f cosine of 65 degree, because we know that the force is just like this. We have two components, one is the normal component, that is perpendicular component, and other one is the horizontal component, that is just like this. So it means for the shear stress we use this horizontal component. Okay, so f cosine 65 divided by area is 0.75 feet square. So f is now 20 cosine of 65 divided by 0.75 feet square. Okay, now we solve this and we get the answer, that is equal to, that is okay. When we calculate this, we get the answer, that is equal to we solve this, we get answer 15.02 pound per feet square. So in order to convert this 15.02 into inches, we just divide 12 square, pound divided by feet square, because 1 feet, as we know that 1 feet is equal to 12 inches. So if means if there is feet square, so we use 12 square. So we get answer, that is 0.1 pound per inches square. Okay, this is the shear stress.